All right, in this video, we're going to be working CalBC Homework 1.2, which is really about how limits relate to asymptotes on the graph of a function. Okay, so the first set of problems, we're going to be finding the vertical asymptotes. And remember, the cause of a vertical asymptote is, at least if you've got your function fully simplified, you're going to be an x value where you'd be looking at like non-zero number divided by 0. Okay, so what we're going to do for these is we're going to go and kind of grab the denominator of each of these things, set it equal to 0, and get some x values. So this would have a vertical asymptote when x plus 3 is equal to 0, and that's going to be where x equals negative 3, and that's also going to be like, the equation of the vertical asymptote. And over here, same idea. We're going to grab the denominator, take it over here, and set it equal to 0. Okay, this is a second degree polynomial, so we're going to have to try to factor it. We're going to look for two numbers that multiply to negative 2 and add to negative 1. I'm going to get x minus 2 multiplied by x plus 1 equaling 0. And so that would happen if x was equal to 2 or if x was equal to negative 1, and these will be the equations of the asymptotes. Okay, with the third one, okay, we're going to be interested in where x squared plus 1 equals 0. And actually, you're not even going to be asked something like this in this class, because it's like venturing on something that's out of bounds. But if you were to get something, like x squared equals negative 1, and you were to try to, like go into the realm of complex numbers in AP calculus, that's always the wrong thing to do. We don't deal in in non-real complex numbers in this class. So we would just say no vertical asymptote. The last one, 1 over e to the x minus 1, just like the other ones, take the denominator off to the sides, set it equal to 0, and see what happens. Okay, well, this one, if I'm going to try to solve this equation, and I'm going to try to get the x down out of the exponent, I need to isolate the exponential and take a log of both sides. So I'm going to add 1 to both sides, and I'm going to take the log of both sides, so x equals the natural log of 1. I don't really care how you convince yourself of this, but you're going to need to know that that's x equals 0, and that's going to be the equation of the vertical asymptote. Here, just do a little bit of that. So I clearly displayed all my answers. Oh, and there's another one. I didn't realize that. Okay, so 1 minus sine of 2x is the denominator. We can figure out where that's equal to 0. Okay, probably for the most part in this class, in AP Calculus, you're not going to have to find like all of the infinitely many solutions to this equation. What you're probably going to do instead is, have the domain of f restricted probably to 0 to 2 pi. And so that's just what I'm going to say right here. Okay, so I'm going to solve for sine x by subtracting 1 from both sides, dividing both sides by negative 2. And then thinking, okay, sine x equals a half. I know where that's going to happen on the unit circle. That's probably not the diagram I want to draw. All right, that's more like it. Okay, so sine is the vertical displacement from the x-axis. A half is really not very far on the unit circle. It's kind of like the first thing. So it's going to happen right here and then right over there, right? These are the places where the y-coordinate on the circle is a half, or where it's like really small. So it's going to be pi over 6 and 5 pi over 6. And so at least on the interval 0 to 2 pi, these are going to be the locations of the vertical asymptotes. Still barely visible to you. Oh, throw a box around that, be happy, move on. All right, now we're going to find the value of the limit. Okay, and these are looking like, these are these one-sided limits at the location of a vertical asymptote. So these are going to be either positive infinity or negative infinity, most likely. If you just look at x approaching 3 from the negative side, if you plug in 3, you're going to get 2 minus 3 is negative 1 divided by 0. That's vertical asymptote. So we're definitely working on top of vertical asymptote. This is kind of the question is like, what's actually going on here? So limit as x approaches 3 from the negative side. Well, I could just mark this as like, 2.9 or 2.99. We're not going to have a sign change in either the numerator or the denominator in that interval right there between 2.9 and 3, so I think that's going to be all right. Right. I'll draw in here that this is a vertical asymptote when I go to make the graph. But if I plug in x equals 2.9, I'd have 2 minus 2.9, that's a negative number, divided by 3 minus 2.9, that's a positive number. Okay, so negative divided by a positive is negative, and we're approaching a vertical asymptote. That's telling me that this limit is negative infinity. Over here, as x approaches 1 from the negative side, okay, so I'm going to just draw the same diagram. It might just, or negative 1 from the positive side. I feel like I said that wrong. If we look at this, and plug in x equals negative 1, I'm going to get 1 over 0. That's definitely a vertical asymptote. Okay, and then we're going to say, all right, from the positive side, that would be like negative 0.9. And so go off to the side and say, all right, negative 0.9 plus 2, that's a positive number, divided by negative 0.9 squared, that's 0.81, minus 1, that's going to be a negative number. Okay, so that's going to be positive divided by negative. Once again, that's a negative number. So over here and approaching negative infinity. Right there. Okay, so I'm going to conclude that this limit is negative infinity. Okay, with this one, okay, if I plug in x equals 1, I'm going to get 1 in the numerator and natural log of 1 in the denominator, and that's going to be 0 in the denominator. That's vertical asymptote. So I'm going to go over here and say, write 1, and I'm going to need to go to the positive side, so that's like 1.1. Alright, and then I know that this is the location of a vertical asymptote, and the question is, what happens when I plug in x equals 1.1? Okay, well, if I plug in 1.1 to the numerator, that's a positive number, divided by the natural log of 1.1. That might be a little tricky for you, you might not have thought about that for a while. Positive divided by, we're not quite sure right now. But what I would remind you, I think the easiest way to remember this is to just kind of know what the shape of the graph of y equals log x looks like, and that's really going to be the way to go. That's the x-intercept that happens at 1, and after 1, natural log of x is positive. His idea is what exponent you would put on e to get 1.1 would be like a small positive number. You'd be taking like some, 10th root of e or something. I don't know. If it's 0.1, who knows? But that's actually going to be pretty close. But what I'm saying is this is a positive number. I think, reason I might give would be, maybe I'd just say, like right there, okay, it's positive. And so that's the reason for that one. I'm going to go over here, say, okay, positive divided by positive is positive. We're approaching a vertical asymptote, so that's going to be this limit equaling positive infinity. Okay, x approaching pi from the positive side of 2 divided by sine x. Okay, sine of pi, that's going to be 0. Yeah, and so I've got 2 over 0, it's vertical asymptote. Okay. So pi here, and if you're thinking about, you could do 3.15 or something, but I think the best thing to do is just do the next stop on the unit circle, which would be 7 pi divided by 6. Up to you, though, depending on how we're going to draw a unit circle diagram either way, so I don't think you can necessarily go wrong. 2 divided by sine of 7 pi over 6. Okay, so if I draw the circle, think about the x-axis, really that's the one that's going to matter because sine is the distance from that. 7 pi over 6 is down here, the vertical displacement will be negative. I'm in the third quadrant, that's where sine is negative. So I'm going to say that sine of 7 pi over 6 is a negative number, positive over negative. It's going to be right here, okay, approaching negative infinity. But you could have also said like 3.15, you know, as I go in and write my answer. You could have said 3.15, and it's, you know, a little bit bigger than pi, around right there where the y-coordinate on the unit circle would have gone negative. So I don't think it really much matters what you're choosing there. It's really more the thought process of like what's happening when x is a little bit bigger than pi. Okay, now we're going to think about the horizontal asymptotes to the graph of a function. And so when we're thinking about that, we need to be considering the limit as x approaches infinity and the limit as x approaches negative infinity. So we're going to be taking the limit of g of x as x approaches infinity and the limit as x approaches negative infinity of g of x. Okay. Now, the ones where it's really going to make a difference is going to be the exponentials, but I'm seeing that on both of these, so yeah, we're going to want to consider both of these. So for this one, let's start by taking the limit as x approaches positive infinity. And, you know, provided that we've got e to like the positive x like we do here and there, this is where we're just thinking about relative growth rates. And the biggest growing thing on top and bottom is the exponentials. So this limit minus e to the x divided by 3 e to the x minus 5x plus 2. Okay, so we're thinking about, you know, this thing here against that thing, and this is going to have a limit of negative 1/3 because we're going to divide the leading coefficient. Okay, because it's an exponential with the same base, it's growing at the same rate. Okay, but we need to think about the limit as x approaches negative infinity as well. Of, okay, 2x minus e to the x. Okay, well that e to the x is going to go towards 0 as x approaches negative infinity. For reasons, you know, that we discussed in class, or in the, you know, the video of the lesson. So as x approaches negative infinity, that's going towards 0, so is that. Okay, so now what I'm left with is, you know, like a 2x in the numerator and a negative 5x plus 2 in the denominator. So I'm looking at, you know, the ratio of the leading coefficients there, and that's going to be 2 divided by negative 5. Okay, so we're going to say that our horizontal asymptotes are y equals negative 1/3 and also y equals negative 2/5. That's what we're asked to do, find the equations of the horizontal asymptotes. Right, over here, same exact idea. I'm going to say first we'll take the limit as x approaches positive infinity, and that's where we're thinking about just overall relative growth rates. The biggest growing thing is going to be the exponential in the numerator and the exponential in the denominator. But these are not like the same exponential, right? 3 to the x is not the same as 4 to the x. 4 to the x will grow faster than 3 to the x. So since this thing is growing faster, it's going to be what, you know, dictates the overall behavior of the fraction. The denominator is growing faster. That's going to have a limit of 0. And as x approaches negative infinity, though, if we look at the same fraction, both of those exponential pieces are going to go 0. The 3 to the x and the 4 to the x. So, you know, as these things go towards 0, because x is approaching a large negative number, and we're taking 3 to a large negative number, that's like 1 over 3 to a big power, or, you know, 1 over 4 to a big power. These things are getting close to 0. And we're left with a square on top and bottom are the things that are growing. So I'll look at that and this one. So this would be 2 over negative 5 again. Okay, so just, yeah, probably, I bet I was using copy paste a little too aggressively there. Okay. And you know, as a result, my horizontal asymptotes are y equals 0 and y equals negative 2 over 5. All right. Okay, on this one, when we see the square root of x squared, that's the thing that can possibly have a double horizontal asymptote. And it's a little weird, and I'm not going to go into, like, you know, the deep algebra steps of what's going on here. But if you're interested, yeah, I'm sure I've done that. You know, I did that on video for class for the lesson. This one you just need to remember, okay, as x approaches positive infinity, the square root of x squared, it's pretty much x. And so the square root of 16x squared, that's pretty much like 4x, especially as x gets much bigger. That plus 1 isn't going to make a big deal. We're taking the square root, so I'm going to say, okay, 2x plus 1 over something that's a whole lot like 4x, that's going to track towards 2 over 4. Okay, and then as x approaches negative infinity, though, kind of the same thing's going to happen. I'm going to have 2x plus 1 in the numerator and something in the denominator that's a lot like 4x. But really what it's like is 4 absolute value of x. Because if you take a negative number and you square it, multiply it by 16 and add 1, you're going to have a very positive number. And you take the square root of that, that's going to be a positive number also. So I'm going to say that this is going to come back instead of positive 2 over 4. This one's going to be negative 2 over 4 because x is approaching negative infinity. And the numerator of this fraction, as x approaches negative infinity, has to be a negative number. So if I've got a negative number right here, divided by a positive number, I've got to be approaching something that's negative, if I'm approaching anything at all. So that'd be negative 2 over 4. And as a result, I'll say that my two horizontal asymptotes are y equals 1/2 and also y equals negative 1/2. Okay, the last one here is 1 over 1 plus e to the x. Okay, that's the same as always. We're going to consider the limit as x approaches positive infinity. And so since this is e to the positive x, we're just thinking about the relative growth rates. This thing grows much faster in the denominator than it grows in the numerator because the numerator doesn't grow at all. It's just stuck at 1. And as x gets bigger, so does e to the x, and e to the x plus 1 is growing. Numerator is staying the same. That's exactly the picture of having like a limit of 0. All right, so the limit is x approaches negative infinity of this, 1 plus e to the x. So I'm taking e to a large negative power. That's going to go towards 0. So this is going to equal 1 over 1. And so my two horizontal asymptotes are going to be y equals 0 and y equals 1. Okay, and I think that's a really good picture of what, a function that has multiple horizontal asymptotes can look like in this class. It's probably going to be an exponential, occasionally the thing with the square root of x squared. Okay, now we're just going to find the value of the limit, and that's probably what you need the most practice on. It's just like, here's a limit as x approaches infinity, go ahead and do it. The ones where x is approaching a number from one side and we're doing the asymptote analysis, I think we've done enough of those. So the first one, if I was to rewrite this and like simplify by distributing out the numerator and the denominator, what would happen is I would get, because really I'm seeing that I've got second degree on top and second degree on bottom. So the degrees are the same. I'm going to be approaching some real number that's the ratio of the leading coefficients. But if I distribute this out and I do FOIL on top, right, it'd be x times 6x is 6x squared. And then it'd be like plus some other stuff that I'm not really caring about because I only care about the second power term. And then if I were to square the denominator, it's not just going to be 4x squared plus 9. There's going to be, the two middle terms I'd have to think of. But those middle terms, or the 9, those aren't really contributing anything, and all I'm interested in the fact is that it's 4x squared plus some other stuff. And we know that if we have that, we can just kind of look at the ratio of the leading coefficients, and I'm going to get 6 over 4, and that's going to be the value of the limit. Okay, this one over here, I'm seeing largest power, second power here versus this third power, so that's the biggest thing, and it's in the denominator, so this limit is going towards 0, regardless of the other stuff, the 300x and the 4000, that's just there to distract you, right? As x approaches positive infinity. I don't think I really emphasized that, but you see that x approaching positive infinity at the start. That's when we're thinking about relative growth rates, what's growing fastest. As x approaches negative infinity, we might need to be a little more careful, right? Think about it, we're looking at any exponentials. Looks like we're not in this case, but I'll just point that out. Then what we're going to do for this one is just kind of look at this is going to be the same as the limit as x approaches negative infinity of, we'll just divide the biggest thing on top and bottom. So negative 5x cubed divided by x squared. So that's equal to the limit. And that's not in, like this right here, I mean, it's true that the limits are equal, but that's a little fast for my taste, but that's exactly what we did in AP Pre-Cal last year. So I know that some people in my class right now, you might be coming in really familiar with this process, and so that's what I'm just going to stick to. And, after a discussion in class, I found out that, the equal sign that I'm pointing to in red, it is actually true. It's equivalent, the limits are equal. So what I wrote there is not untrue, it just feels a little fast, like I said. So this is going to be the limit of negative 5x, and we know what negative 5x looks like. It's a line with negative slope. And so if I think about x approaching negative infinity, that's, right here, that's going to be positive infinity. You probably didn't need to do that much analysis to figure that out if you were, just kind of thinking about what the graph looks like. But if you want to do that type of analysis, that will get you to the right answer. Okay, as x approaches positive infinity, we're thinking about the fastest growing thing. And, 5x and 2x, those don't grow very fast, but they are definitely growing faster than natural log x, and sine x doesn't grow at all. So I'm just going to be thinking, all right, this is pretty much going to be like ratio of 5x to negative 2x, and that'll be 5 divided by negative 2. And so we'll just leave it like that. That's a safe place for us to stop in this class. Okay, x to the 99 divided by e to the x plus log x. Okay, so this is like what grows faster, the high powers or the exponential. The exponential always grows faster. Provided that the base is bigger than 1, it is actually growing. Because if the base was like a half, that would be exponential decay. It would be a whole different story, but I really don't think you would run into that situation in this class. Really not out to trick you. It's just like, do you know which grows faster, exponential or x to the 99? It's going to be exponential, so it's the biggest grower I've got. And so since it's on bottom, that's going to equal 0. Right, over here, again, as I'm looking at this, okay, the biggest thing I see is the 2x cubed. Oh, but I'm going to need to say, okay, well, since it's bigger on top and I'm approaching negative infinity, I need to figure out, is this thing approaching positive or negative infinity? So I'm going to say, all right, I'm going to get rid of that and say this is equal to the limit as x approaches negative infinity of 2x to the 3, taking the biggest thing from the top and the biggest thing from the bottom. Okay, so that's going to be equal to the limit as x approaches negative infinity of x squared divided by 2. Okay, now x squared divided by 2, you've probably graphed something like that before. It's a parabola, it's a little wider than usual. Okay, that's not my best sketch ever, but the idea is, okay, as x approaches negative infinity, over here, y is approaching positive infinity. So I'm going to say equals positive infinity. Okay, now this next one, x is approaching infinity. Okay, I like that. I was kind of waiting for something like that. We're taking the limit of this whole thing, right? And as x approaches infinity, this 3 is kind of unimpressed, right? It's just still 3, and it's like, okay, x is approaching infinity, that's great. That's going to impact the fraction. And we're thinking about x to the 5th versus 2 plus e to the x. E to the x grows fastest. It's in the denominator, so this limit is going to equal 3 plus 0. And while 3 plus 0 is definitely a safe place to stop in this class, I think you would be able to simplify that and say, okay, that's going to equal 3. Because although you don't have to simplify like on the quiz or in the free response section of the test or the AP exam, we do a lot of multiple choice in here, and you do have to simplify for multiple choice because 3 plus 0, that's not going to be one of your choices. All right, as x approaches infinity, this is kind of one of those composition of function limits like the last one, but this is a lot easier. What I'm going to recommend is you just work from the inside out. So I just want you to think about what's happening to this fraction as x approaches infinity. Okay, that x is growing, the numerator is staying the same, so the fraction as x approaches infinity, it's 1 over a large number, it's getting really close to 0. So I'm getting really close to taking the cosine of 0. So that's going to equal the cosine of 0 as x approaches infinity. And in this class, we're going to need to be able to, evaluate that. So I'll go over and draw myself a unit circle for reference. Okay, theta equals 0 is over here at the right edge. Okay, that's at the, you could say it's at the point 1, 0 if you'd liked, or you could just say, okay, this is 1 unit away from the y-axis horizontally. It's the biggest that cosine could be. It's the farthest to the right I can go. Either way, this is going to equal 1. All right, and so we've done those. Great, and we can move on. All right. Write an equation of an asymptote to the graph of y equals f of x that must exist if the limit statement is true. Okay, I really like these questions. I've been finding more multiple choice questions like this in AP Classroom, so I've been using these quite a bit lately. Okay, now what I'm going to just first emphasize is if we are looking at x approaching infinity or negative infinity, that's going to be a horizontal asymptote. Okay, and if we see that a limit comes back infinity as x approaches some real number, that's going to be a vertical asymptote, right? Because the y coordinates are running off. Vertical asymptote. All right, so that's going to be, okay, yeah, I'm seeing that here, I'm seeing that there, the limit is infinity. Okay, so those are going to be vertical asymptotes. And so since I've got a horizontal asymptote, this is going to be y equals some number, it's going to be y equals 2. Over here, y equals 0. Okay, so if you have a good idea about what the equation of a horizontal line should be and have a good idea of like the connection to the limit statement, this can be a very easy question. But when there's 4 answer choices and all of them look legitimate, it could also be tricky if you weren't kind of on top of it. Okay, so vertical asymptotes are vertical lines, and those have an equation like the set of all points with the same x coordinate. And so, look, like what else could x be, right? It's going to have to be x equals 3. And over here, it's going to have to be x equals 1. Because what else would it be? If you think about it, the closer x gets to 1, the bigger f gets. It gets closer to positive infinity. That's kind of the same idea as f has a vertical asymptote at x equals 1. It's just a little more descriptive. All right, finding the value of the limit. Here's another one of these with it could be a double horizontal asymptote. What we're going to do is we're going to kind of just look at this. And so I'm going to say that's equal to the limit as x approaches positive infinity of negative 2x in the numerator divided by, let's say, the 3x, but really it's the absolute value of 3x because we're taking the square root of x squared. Now in this case it doesn't really matter because x is approaching positive infinity, but I think it's going to matter on the other one. All right, so as that happens, I'm going to be approaching the numerator is negative, the denominator is positive, that's going to be a limit of negative 2/3. All right, and then over here, yeah, this is really where it's going to matter. And so I think, just looking at these two things, I'm going to pull those off to the side. That's a sneak preview in case you didn't see in the lesson why these have 2 horizontal asymptotes. It's related to that function absolute value of x divided by x, which we looked at in the first lesson. So that's absolute value of 2x divided by x. Okay, so that's just one of those functions with a jump discontinuity, and as x approaches negative infinity, this is going to be, constantly equal to negative 2, that second fraction. And they have the same limit, and so that's going to equal negative 2. Okay, now we only got 2 problems left here. This is a relatively quick one. G has a vertical asymptote at x equals 5 and a horizontal asymptote at y equals 6. Okay, vertical asymptote at x equals 5 and a horizontal asymptote at y equals 6. Okay, so what's going to tell us about the horizontal asymptote is this like ratio of leading coefficients I see, because they're both x squared over x squared. So I'm going to say a over 1 equals 6. So that's just going to be a equaling 6. Right, and then vertical asymptote at x equals 5. Well, that means that when x equals 5, I have to be dividing by 0. Okay, so I'm going to say x squared minus b equals 0 when x equals 5. So I plug that in, I get 5 squared is 25 minus b equals 0, and that's going to give me that b equals 25. And what are the values of a and b? A equals 6, b equals 25. And you can see why I generally try to avoid lowercase b. This looks exactly like 6 when I write it. So the graph of this function h has the asymptote shown, which I'm going to really emphasize. Y equals 2 is a horizontal asymptote, and x equals -1 is a vertical asymptote. What is the value of c plus d? Okay, well, again, if I'm saying, okay, negative dx cubed divided by 1x cubed, let's say, all right, negative d divided by 1 equals 2. That's going to be telling me that d needs to equal -2. And then x equals 1. This was x to the 3 minus 3c. So x to the 3 minus 3c would equal 0, because that's the cause of a vertical asymptote. At the point where x equals -1. Okay, so -1 to the 3 is -1 minus 3c equals 0. I'm going to just keep solving at that. -1 equals 3c. That's telling me c is -1/3. And they asked me for c plus d. c plus d is going to be -2 plus -1/3. And I guess that's d plus c, but that's going to be the same thing. -2 would be 6/3, so it's going to be -7/3. Okay, yeah, and that's going to be all the problems in this set, so that's all for this video. Thanks for watching.